You do hear that a little bit of a hum in the background, as I said, because the fan is running. It's really hot, but we must continue. So now you are asking me, how do we know that human activities have added to climate change or have modified? Remember, we said the climate always changes, but now we are saying human beings are adding something to it and making things change faster. Warming, sea level rise, glacier melt, extreme events as we just talked about, and so on. How do we do it? I already mentioned several times that there are equations that take the energy coming from the sun and they represent the fluid that the atmosphere is and the ocean is with their different heat capacities and densities, and how the earth is moving and how the Coriolis affects things in the northern hemisphere and the southern hemisphere and so on. And they solve these equations, which are very, very complicated, and they can only be solved on a computer and so on and so forth. How do you think about it? Let's say you understand a little bit about a video game you're playing, or let's say you're trying to build a car that can drive itself. So you are doing a computer graphics and you're telling the car is here and it has a sensor. It can sense that there is an intersection and that there is a car coming there. There are people crossing here and there's another car going there, and there are buildings on the sides and so on and so forth. It's getting signals from a tower that's there, and it can watch the traffic light and so on and so forth. So you have designed the computer and the software in a way that it can sense everything and slow down or stop for the red light and move carefully when there is a pedestrian in the way and so on and so forth. This is a model. You are taking the car, the roads, the people, the signals, and on a computer you are modeling everything to design properly. So similarly, you have a model of the earth system with its energy balance and momentum. So winds moving, ocean currents, heat moving, humidity and water vapor and all those good things. So how do we know humans are causing climate change? So we take data from the past, let's say from 1850 to 2019, and we are giving it to a model. So the global surface temperature change since 1850, we have already seen some of this, and we are looking at time going here from 1850 to 2019, and we are measuring along the way the greenhouse gases that we can measure and say it's produced by the human beings. And there are natural changes happening like sunspots and volcanoes and so on, and human beings have also produced dust and all these black carbon and pollution, which can actually cool the temperature because they block the sunlight and so on and so forth. So we can give it all these forcings, as we call it. And forcing, as you remember, is anything that changes the energy balance of the incoming solar radiation and outgoing thermal radiation. So if we had all the greenhouse gases without the cooling from the dust that we are also producing, then the warming would be here. And we also know what things changed naturally in terms of the sunspots and the volcanoes and so on, and we can then compute how the temperature would have happened in the model if we didn't tell it that greenhouse gases are increasing and dust is increasing and so on. So this is what we observed, which is a combination of human impacts and natural causes. And if you take out the natural causes, what happens? If you take out the aerosols, what happens? And so on and so forth. So in this model, it's like what happens once the people have moved out of the way and once the light turns red to green, and if this car is not stopping on time and continues to go through a red light illegally, and so on and so forth. So in the model you can do similar experiments saying I have the simulation I need from 1850 to 2019, 2019, but now I will not tell you how the CO2 has increased or how methane has increased and so on. So it gives you a difference between what could have happened if there was no change made by us and what happened because we made some changes. This is called detection and attribution. A complicated word. If you don't understand, do not worry about it. If you're old enough, you know that detection means you are detecting a change. You are a detective who is measuring temperatures and greenhouse gases, and you say, I see that greenhouse gases have increased and I can use some methods of science to say this has come from fossil fuel burning, and I have measured global temperatures and I know it has warmed so much, and then I can use the model to say it has warmed so much because it has added to the natural change that would have happened if we were not increasing the greenhouse gases and if we were not increasing the dust and so on. Aerosol, AEROSOL, is anything that is floating around in the atmosphere. It can be carbon particle, it can be dust particle, it can be pollen, it can be even bacteria and so on and so forth. Anything that is affected by the circulation and can absorb sometimes or not absorb solar radiation or thermal radiation and so on and so forth. So we can actually estimate how much of the energy is being trapped by the greenhouse gases and how much of it is being taken out by the other factors like volcanic eruption and so on and so forth. I won't go into the detail, but again we are going here now from 1750 to 2010 or so, and we are looking at volcanic eruption. So when a volcano goes off, there is a sudden cooling, so there is negative forcing. In other words, you are blocking the sunlight and not allowing energy to come into the atmosphere. So you see many volcanoes have gone off that we know about, and we know how strong they were and how much sun blocking they did and so on. We know how CO2 has increased, so it has increased the radiation captured, thermal radiation not allowed to go out. There are the aerosols, and there is the methane and nitrous oxide and ozone and other greenhouse gases which have done. So this is the rate of change of how we have created a forcing, how we have created an imbalance between the incoming radiation and the outgoing thermal radiation. So what is the point of this? The point is we can, in a very good way, very scientific way and fairly reliable way, estimate how much additional energy we are trapping and which part of the greenhouse gas is doing it, which is adding to capturing the thermal energy from going out, and which is actually reflecting the sunlight and so on and so forth. And then you can come back to the extremes and close out the chapter. From 1998 to 2005, Miami Beach, Florida had 16 floods. From 2006 to 2013, there were 33 floods in Miami Beach, Florida, more than twice as many. This is an indication that things jumped, and then you have to go back and show that in a world where there were no human beings making any change. If you're old enough, you may understand this word. It is called the counterfactual world. There is a factual world that we are observing, and there is a counterfactual world where we tell the model, what if human beings were not around and we were not increasing the greenhouse gases and the aerosols and the dust and so on and so forth? We can use the differences to say for sure whether the probability of the floods has been increased because of the greenhouse gases we are adding. So generally, the regions that are already wet are generally getting wetter, but dry inland areas are facing other problems, and it is likely those problems will start with heat waves. So in the next chapter we'll talk about heat waves, but it also means you have to worry about where we are headed into the future and what is happening to human health and so on and so forth. So it's complicated, and it's obviously not easy to understand. So if you don't understand some parts, write down the questions, ask me on my channel or ask your teacher, father, parent, neighbor, friends, siblings, and so on, or just ask me and try to learn. Or if it's too difficult, just listen and wait till you grow up, and then you will come back and learn again. These podcasts are not going anywhere. They are going to be sitting on YouTube for a while. Okay, so let's meet in the next chapter, which indeed is about heat waves. Okay, if there is warming going on and the warming is creating more humidity, then you expect that there will be heat waves. Heat wave is a word. It's not always an actual wave moving, but if the temperatures are expected to be something and then you are much warmer than that by some definition, then it can be called a heat wave. And can we predict the heat waves using these models that we mentioned? That's the key factor that we're always trying to understand, because if I can tell you next day will be a heat wave, your mom may say don't go out to play. She may tell herself, I better dress properly and carry an umbrella, or travel by bus and not walk, and so on and so forth. So you can take action to reduce the impact of the heat wave. Saying now what may happen today are called early warning systems. You may see on TV, when your parents are watching TV, you can ask them, where is the weather forecast? So they may show you the weather forecast section, which says what the weather will be like tomorrow or the next few days. So these are ways of telling people how to prepare, how to dress, and how to travel, and so on and so forth. Okay, see you in the next chapter.